Hello viewers, welcome back to another section of my multivariable calculus tutorial. In this tutorial, we're going to solve a double integral problem in the polar coordinates. In our previous video, we solved a similar question and we move ahead to solve more questions. So don't forget to like, to subscribe, and also share as we're going to solve more questions of this to better understanding in calculus. So once we have this, integral from -1 to 1, then integral from 0 to square root of 1 minus x squared. Then the function I have here is x squared multiplying x squared plus y squared all to the power what? Squared. dy dx. Meaning we integrate the inner with y first and the outer with x. And the inner goes for this limit, outer goes for this limit. The first way to approach this problem is by taking the limit out. So y will be greater than or less than 0, less than or equal to what? Square root of 1 minus x squared, like that. So the x is going to take the outer, so x will be greater than or equal to -1 but less than or equal to 1. Now in the polar coordinates, we are interested in two parameters, our r and our theta. So in our r, we are going to find the radius, and theta will be the angle that radius is going to make with the xy plane. So here, let's make a simple sketch. I'm going to have my y and my x here. X is spanning from -1 to 1. That is, x is equal to -1 and x is equal to what? 1, like this. Then y is spanning from 0 to positive of this function, meaning this function lies only in the positive y part. So it's going to start from 0 to top like this. It doesn't come down to the negative y, only the positive what? Y. Take note of that. So with this thing here, you can realize that our radius, which you can mathematically compute from here, or you can use the graph. So for mathematical computation, y is equal to the square root of 1 minus x squared. Then y squared plus x squared will be equal to 1, right? So we get r squared to be equal to 1. Therefore, our radius will be what? 1. And hence, the interval will be from the origin 0 less than r less than 1. Or from this drawing, you can realize that the x, or the maximum this circle is going, is from 1 to -1. Hence, it's 0 to 1. Now, what we are interested in is the whole theta. Theta is the angle is going to make, the radius is going to make with the whole xy plane. And you realize that it doesn't come to this side. So we start from 0, then it spans here. So it's going to be greater than or equal to 0, but less than or equal to what? Pi 180. Once you have this, you are going to go to compute. So I'm going to have integral my theta out 0 pi, inner 0, then 1. Now x in the polar coordinate is simply equal to r cos what? Theta, right? So I'm going to have r cos theta all squared, since I have x squared out. Then my x squared plus y squared gives r squared. Then all squared dr d theta. Don't forget the r here. So here we're going to have integral of r to the power, here is squared, so r to the power 4 for this side. Then r squared cos squared theta, all multiplying our r dr d theta. Then our limit comes in 0 1 0 pi. Let me further simplify the function, and I'm going to get, here is r to the power 6 multiplying r to the power 7 cos squared theta dr d theta, integral from 0 to 1 0 to pi. Once I have this, I integrate the inner, so I get 0 pi r to the power 8 over 8 cos squared theta 0 to 1, then d theta. So I'm to compute what I have here. When I put 0 here, everything will be 0. I'll take the only the upper limit, so 1 over 8 cos squared theta d theta, and I bring in 0 to pi here. Integrating this, how are you going to do that? How are you going to do this? 1 over 8 is a constant, so it will come out of our integration. Integral of what? 1, so cos squared theta d theta pi. Now, when you are integrating this trick, what you are going to do is you use identities. So what you're going to realize is this is the same as cos squared theta is the same as 2 cos. So let do it this way. Let's start with the expansion. If you have cos 2 theta, you realize that it's the same as cos squared theta minus sine squared theta, right? Minus sine squared theta. So meaning with this, I'm going to have this place replaced with 1 minus cos squared theta. So I'll get 2 cos squared theta minus 1. So if I want to make cos squared theta, it's the same as 1 plus cos 2 theta all over what 2, right? So integral 0 to pi of this. Then from this side 2, 1 over 8 is out, then the theta. You realize that we take half out, so I'll get 1 over 16 integral 0 to pi 1 plus cos 2 theta. I further integrate this, and I'm going to get integral 0 to pi 1 plus integral 0 to pi cos 2 theta. Simply 1 is going to give me pi, that is, I'll get theta, so I'll put pi here. Here will give me pi, plus this side I'm going to get 1 over 2 sine 2 pi, so sine 2 theta from 0 towards pi, right? Yes, so I'm going to get pi plus half. When I put 0, everything will be 0. Then sine 180, what am I getting? That one, everything is going to be 0. So finally my answer will be 1 over 16 multiplying pi, giving me pi on what? 16. So this is the end of this video, and you just go through. It's very simple. You need your r and your theta, the limits, then finally you change every x and y to r. Thank you for watching this video. Don't forget to like and also subscribe.